All right, we're on to lecture 15, part B. Now, in this part, we're going to keep working on balancing reactions. So we're going to do another example, an example that's a little bit different. And while we're at it, we're going to learn about another type of reaction. So in part B, we'll do another balancing example and then talk about types of reactions a bit more. Okay, so let's go ahead and move on. And for this one, I don't actually have a video of it. So we're just going to talk about this reaction and then try to figure out what's going on. So in this example, we have NaI is reacting with FeNO3 and it is turning into NaNO3 and FeI2. All right, so those are the formulas, but what the heck? I always like to think about what do we call these things? Oh, let's see if we can figure that out. So let's see, first off, NaI. NaI over on the left-hand side here, this would be called sodium. And then I is iodide, so because it's part of a compound, sodium iodide. And then let me adjust my camera just a little bit. And then FeNO3 that one would be called, Fe is iron, so this would be called iron. And then NO3 is actually a polyatomic. Oh, you may not know that off the top of your head. Let me tell you. NO3 is called nitrate, so this is iron nitrate. And then if you look at where iron is on the periodic table, do you need a Roman numeral? Oh, yeah, you do. So the name of this thing, nitrate, is actually a -1. And there's two of them. So the iron in this case, it would be actually iron 2 nitrate. The charge on the iron would have to be +2. Iron 2 nitrate. Now, moving over to the right-hand side, what do you call these guys? Well, oh, let me give you a chance to think about one. This guy right here. NaNO3. What do you call NaNO3? Oh, I hope you know it. It should be called sodium nitrate. Sodium nitrate. And then that last compound, FeI2. Fe is iron, and that's iodine, but it's part of a compound, so we call it iodide, iron, iodide. And again, oh yeah, iron needs a Roman numeral, so it's not just iron iodide. Iodide is -1. Let's see where it is on the periodic table. So the iron would be +2 again. So it's iron 2 iodide. All right, quick review of writing formulas there. All right, so with that, that's what we're doing. We're mixing sodium iodide with iron 2 nitrate. We're making sodium nitrate and iron 2 iodide. All right, so with that, let's go ahead and really get into kind of the new stuff, right? And the new stuff is learning how to balance. So the first thing I'm going to do when I balance this thing, let's make a list of what we got. Let's make a list of what's on the left-hand side, the reactant side. What do we have on the right-hand side, the product side? And if things aren't matching up, we're going to put in some coefficients so that the number of atoms on both sides is the same. So we're going to have to figure out where those coefficients might need to go. So let's start by making our list. On the left-hand side, for sodium, there is 1 sodium. On the left-hand side, for iodine, there's 1 iodine. On the left-hand side, for iron, there is 1 iron. And then, oh, this is where something we haven't seen yet. Now, this one, actually, the next thing I see is a polyatomic, right? NO3. Even a minute ago, we talked about the name of this polyatomic. It's called nitrate, right? So when you have a polyatomic and you see it on the left side and it still shows up on the right-hand side, one way you can deal with that is instead of listing every atom, nitrogen and oxygen, you can treat that polyatomic as a group. So when I make my list, I'm going to say not that there's 2 N's or something on the left-hand side. I'm going to say that there are 2 nitrates on the left-hand side. All right. So one last thing I want to mention about this, just so you don't get mixed up, is that when I said you can treat a polyatomic as a group, that is totally good and it totally makes your life easier. But you just want to make sure the polyatomic is also on the right-hand side. There are some reactions where a polyatomic changes in the reaction. And if that's happening, you can't leave the group as a group. You would have to go atom by atom. So, but if the polyatomic's the same on both sides, just leave it as a group. It'll make your life easier. All right. So with that, that's the left-hand side. Let's go to the right-hand side. On the right-hand side, we're going to do the same thing. Sodium. One of them's. All right. Nitrates is the next thing I see. Again, I could even think of this sort of in parentheses. There's like one nitrate, right? There's one nitrate. On the right-hand side, there is one iron. And then the subscript after the iodine tells me there's two iodines. All right, so that's where we're at right now. Now, with that, let's see how we're going to get this thing to balance. So balancing means anything that's not matching up, you got to get to match up. You can't make atoms, you can't lose atoms. So the number of atoms needs to be the same on both sides. So what atom is out of balance right now? What atom is out of balance? It should be the iodine. Do you notice how the iodine isn't the same, right? So there's 2 on the right, but only 1 on the left. Yeah, that's what I mean by out of balance. So, you know, you can look at the formula too, right? There's 1 there and 2 here. Yeah, that doesn't work. Can't do that. Can't have more on one side than the other side. So we're going to need to balance iodine. Now to balance iodine, we're going to have to put a number, and I think where we're going to need it, we're going to need to put that number in this first blank. What number would you put there to balance iodine, to get the numbers to be the same? You would put a 2. You need to put a 2 right here. Now that doubles everything in that first formula. So that 2 applies basically until you get to the plus sign. So we're doubling actually, let me erase some of this. We're doubling actually the sodium, 2 times 1. And we're also doubling 2 times 1, the iodine, 2 iodines. All right. So things are still not quite right. There's actually 2 things that aren't matching up now. Sodium is goofed up, isn't it? 2 on the left, only 1 on the right. Nitrate is also goofed up. 2 on the left, 1 on the right. So you are going to need to fix both of those. The sodium isn't matching up, and neither is the NO3. Now, to fix both of those, you only need to put in 1 more number to fix sodium and nitrate, to get the Na to match up and the nitrate to match up. So I'm going to ask you a couple of questions about that. Those questions are, first off, there are 4 blanks. First blank, second blank, third blank, and fourth blank going across. First blank, second blank, third blank, fourth blank. What blank do you need to put a number in? Oh, I hope you know it's the third blank. Now, what number are you going to put there? You need to put a 2 there, all right? So if you put a 2 there, that should work because it doubles everything in that formula. So it's like 2 times 1. Now there's 2 sodiums, and there are 2 nitrates that applies to the NO3 as well. And I think we got this matched up, all right? So it's getting a little messy here. Let me erase some of these old notes. All right, so does that match up? I think it does. Everything matches up. 2 sodiums on both sides. Yep. Let me look at my list. 2 iodines on both sides. Yep. 1 iron on both sides and 2 nitrates. So yeah, that is matching up. All right, so this reaction is balanced. We need a coefficient of 2 and then another one on the right-hand side. We also needed a coefficient of 2 in front of the sodium nitrate. All right, so as we learn about balancing, we also are learning about kinds of reactions. So again, let me erase a little bit of this. And let's talk about the kind of reaction this is. So let me go down here. This is an example of a, let's call that double replacement reaction. A double replacement reaction. Okay, so in a double replacement reaction, basically what happens is two metals, we could say it this way, two metals switch places. We'll say it that way. All right, another way that might help you, let's think about it as like generically, right? Compound AB reacts with compound CD. And what happens is A and C switch. So A is going to be hooking up with D, and then B and C are going to get together. So we'd also get, B and C would get together. Okay, so it should look like that. So there's like this double switch going on. All right, so let's again, chemistry, I think it makes more sense if you think about it as like a relationship here. Okay, so this one, what you're starting off with, two happy families. You're starting off with two happy families, but then when you're done, you actually end up with two different families. All right, let's do a little analogy. So it could be sort of like, again, maybe this is my happy family. This is me, and this is my wife. All right, we're a little happy family. And you were in the last video, I talked about how Tom Brady came over and kicked me out of my family, and I didn't like this. Not Tom Brady, I said Brad Pitt, didn't I? Well, and I didn't like that at all, how Brad Pitt was taking my place. Well, this time, it's like I have some other visitors this time. And this time, the visitors, it's not Brad Pitt this time. It's like Tom Brady and, who's Tom Brady's wife? Giselle. And what happens is Tom goes off with my wife. Right here. Tom goes off with my wife. That's like the sodium and the nitrate. But this time, I'm not just thrown out in the cold, all sad and alone. This time, I get to hang out with Giselle. Listen, let's keep it clean here. We're just like drinking coffee or something, right? All right, but at least I'm not all lonely sitting in a field by myself or something. I get to hang out with, this would be like me and Giselle. So there's this double switch. So now we have Tom is with my wife hanging out, and I'm hanging out with Giselle. Oh, I like the sound of this way better than the last one where I was all alone. All right, so if you have this double switch going on, basically two families form two different families. That is called a double replacement reaction. All right, so let's go and continue on, and let's do a quick review of all these kinds of reactions, and let's see if we can pick out what's going on. And so far, we've talked about four kinds of reactions. So let me go ahead and we'll flip over and do a little review about kinds of reactions. Okay, type number one, we talked about combination reactions. Combination reactions, that's marriage. Two things joined together to make one thing. You can see several examples there. Two things joined together to make one thing. That's called a combination reaction. It's a marriage. Second, opposite, divorce. Except we don't call it divorce, we call it decomposition. One thing breaks up into two things. So if you split up a compound into smaller pieces, that's called decomposition. All right. Third one we've talked about, single replacement. This is the sad one. A little family, they're so happy, somebody comes along and breaks up the family. So the new person joins up with, in this case, sulfate, and copper ends up all alone. So one thing is getting pushed out of a compound. Now, another way of saying that, and you can see it up above, basically one element is replacing another element. So one element is kicking out another element. Another way I can help you understand this is this involves an element reacting with a compound. If you start off with an element in a compound, there's going to be a good chance that's a single replacement. Now, in a double replacement, we start off with two compounds. So if you notice that you're starting off with two compounds, and in these two compounds, what's going on is there's this double switch happening. So zinc goes off with, oh, I think zinc goes off with chloride. And then hydrogen goes off with sulfide. A double switch is occurring. That's called a double replacement. All right, so let's see if this is making sense. Let's do a few practice ones here, huh? Can we figure out the kind of reaction? So let me move on. Oh, there's one more I almost forgot. So one we haven't talked about yet is called a combustion reaction. So a combustion reaction, this is the fifth kind of reaction. And in a combustion reaction, that basically means you're burning something. So a combustion reaction involves burning something. Now, what does that mean exactly? It really means you have something, whatever it is, and it's reacting with oxygen. So if you see oxygen on the left-hand side, it's combustion. So maybe I should write that out. Oxygen is a reactant. Oxygen is a reactant. So when you burn something, it's reacting with oxygen in the air. If you're reacting with oxygen in the air, that's called a combustion reaction. Now, it turns out the most common thing that we burn are molecules that contain carbon. So carbon-containing compounds often burn, and when they burn, the other thing you're going to notice is besides the fact that we're going to use oxygen, we also always create carbon dioxide and water. So carbon dioxide and water will be products along with heat, right? So when we burn things, it gives off energy. So this is two examples. Like if you have a natural gas stove in your house or natural gas like heater in your house, this is what natural gas is mostly. It's mostly actually called methane. When you burn natural gas, it reacts with oxygen. So you always have to have oxygen to be combustion. If the thing you're burning has carbon in it, not only are you going to see oxygen, you'll also see the products are carbon dioxide and water. And then the second one would be, I guess, down here. This is burning propane. Propane, again, because it has carbon in it, when we burn it, it reacts with oxygen. We make carbon dioxide and water. All right, so anytime you burn something, it's combustion. Oh, I did one earlier, actually. It was the very first reaction we ever saw. This is combustion. 2. Anytime oxygen is on the left-hand side, that is combustion. So like in that example. Oh, I forgot the 2 here. Bad chemist. Got to have it balanced, don't we? All right. So oxygen on the left-hand side means it's combustion. Okay, with that, let's do a little practice now. All right, there's 4 reactions here. I want to figure out the category they are in. What category are they in? So let's go through, and I'm going to do a couple, then I'm going to let you think about a couple and do a little practice, huh? So for this very first one, it's going to be one of these categories, combination or decomposition or combustion or single replacement. So when I look at this first one, number A here, now what I'm seeing is a little family is here. Aluminum is going to come along and he is going to hook up with the sulfate and hydrogen gets thrown out. So we have a family reacting with an element. The element takes part of the family and kicks out the other part of the family. What do you call that? Single replacement. Okay. All right, let's look at number B here. Number B here. For number B, we start off with 2 compounds. 2 compounds. And what's going on in that one? Sodium is hooking up with nitrate. Silver is hooking up with sulfate. So there's this double switch going on. These guys are getting together, and these guys are getting together. That's what these products are, right? So if you have this double switch going on, that's called a double replacement. All right. There's 2 more here. There's C and D. So I think we're going to try these as little pop-up questions, all right? So we'll see if you can figure them out. What category are those in? So go ahead and try C. Oh, wait, while you're at it, go ahead and try D, all right? Okay, great. I hope you got those right. All right, so talking about types of reactions, fantastic. I'm hoping you're understanding these categories. If not, you can talk to me or we'll do some more examples maybe in our Zoom time if we can. Now, oh, one other thing we're supposed to be practicing is balancing. So let me put one of those up too, a little pop-up one on balancing. Let's see if you can balance this thing. Okay, that's the end of this lecture. Part B, types of reactions, balancing reactions. All right, let's move on. There's one more section we're going to do, part C. Similar topic, a little bit different. So hopefully it's making sense. If not, please let me know. Contact me. I'm here to help you. That's my job. I'm hoping you're doing okay. But if it's not quite sinking in, you can always get a hold of me and we can talk some more. All right, let's move on to part C.